Hello and welcome back to another LeetCode video. So today we're going to be doing problem number 155, min stack. And it says design a stack that supports push, pop, top, and retrieving the minimum element in constant time. And so if you know how a stack works, so a stack is pretty much an array, right? And it has some elements. And the top is the last element in the stack. So it's this one over here. And what pop does is it removes the last element in the stack, and then push adds an element. And so these operations in most languages are already in constant time. So push, pop, and top already gives you an element in constant time. But how do we get this get min? And that's what we need to figure out. So we need to get the minimum element in the stack. Well, how do we know what the minimum element in the stack? Can we just keep track of it somehow? Like, let's say we just put in some numbers, right? And we just put in like 4, 8, 1, 3, 9, 2. How do we know what the minimum element is? Well, we could keep track. We could have some variable that keeps track. So we could just say like, okay, well, our min currently is 2, right? But then what happens when we pop it? Then what was the min then? Like, how would we get it in constant time? We wouldn't be able to, right? Like, we could have a min, like a second min or whatever, right? But then the problem is that none of that is going to be in constant time. So we could have like a min and then, you know, like second smallest, third smallest, whatever. We could do something like that. But then the other problem with that is if you have something like that, right, where you have a sorted list as well, where you have the min and then, the, you know, like, so you'd have another list like this, where you would have, 1, 2, 3, 4, 8, 9. So if you just have another list, and then that second list has the sorted elements, we could do that. Well, actually, no, I don't think we can even do that, because if we're putting in elements, we can't put in elements in of one time into this list. So, but even if we had this, the problem is, like, let's say we didn't pop, like, well, yeah, let's say we popped this 2. Well, we wouldn't even know where the index of the 2 is. And even if we did, if we popped it, then the problem is we'd have to shift all these elements, and so you can't pop from the middle of a list in Big O of one time either. So we're going to have another solution. And so the solution we're going to come up with is pretty straightforward, actually. So let me go over here. And what we're actually going to do is, let me put these elements in again, but instead of just putting in the element, we're going to put in the element and we're going to put in the minimum at the time it was put in. And so let's show how this would work and show why this would work. And so we're going to put in 4. And then the minimum element at the time that 4 was put in is 4, right? And it's pretty straightforward to know the minimum element at the time something's put in, because all you have to do, like, let's say we're putting in this 8, we can figure out the minimum element easily at the time it's put in, because we have two cases. If the stack is empty, then the minimum element is the number we put in, right? And if the stack is not empty, we can simply look at the min element over here and just compare it to the number that we currently have. So the last min element compared to the number we put in, and then whichever one is smaller is the min element. So this would be 4 again. Now we put in 1. Now we have 1. We put in 3. Compare 3 to the 1 smaller. 9, 1, 2, 1. And now we can easily get the min element because we have the min element at the time that the stack frame was created. So we can get the min element in constant time. And then if we were to pop, let's see what that looked like. So we could pop constant time, okay. Now you can see the min element is still 1. Okay, let's say we pop again. Min element is still 1. Pop again. Min element is still 1. Pop again. Min element. And now the min element that we're here, now there is no longer the 1. And so the min element will be 4. So you can see using this kind of thing, we can easily get the min element in constant time, where we just say, like, at the current time of creation of some frame, what was the min element? And if we get rid of that, then we know what was the min before that. And so that's pretty straightforward. So let's actually code that up. I think most of the rest of it is pretty easy. So we need a stack, right? So we're gonna have a self.stack here. Push is just a big O of 1. Append, or, you know, most programs have some kind of append operation where you just add to the end of the list. That should be in big O of 1. So stack dot append. And remember, we're going to be pushing not just the element, we're going to pushing the element. Oh, so we need to actually do something here before we do that. So we need to say if, so we need to say if self.stack. We need to actually get this value, right? So we can just say, like, min element is whatever. And we can just say for now min element equals val. And then, so remember, if we do have a stack, we need to minimize the min element. And so that's going to be min element equals min of self.stack. It's going to be the very last item in the stack. And remember, if we're storing value and then the min element, that's going to be 1 here, right? Because we are storing value and then the min element. So we want the element at index 2 in the stack, or index 1. So the last item at index 1. And it's going to be the min of that or the value. And now we can simply pop it in or push it into the stack, right? So self.stack.append. And then we're going to append value and min element here. Okay, now pop, pretty straightforward. We want to remove the top element in the stack, so that's simply going to be return. Oh, actually, so what we want to do is we want to get the value here, right? And so to get the value, we can just pop and then store the value. So it would be something like val, and then the other thing we don't care about equals self.stack. And I do think that for most of these problems, they're not going to pop from an empty stack, but if they did, we'll yeah, so non-empty stack. Okay. So yeah, so when we pop, we have a value and we have the min element, and here we want the value. So this is going to be the value, this is going to be the min element. The reason we use underscores is because we don't actually care about the min element. When we pop, we just want the value. So top is same thing, and except we can even do it like this, return self.stack dot. So remember, it's going to be the last item in the stack at index 0 is the value, and then min element is going to be at index 1. Okay. Then we need to get min, and that's also straightforward, right? We're just going to, whatever stack we currently have, that's just going to be the item in the very last, like at the very end of the stack, and it's going to be the second item in there. So it's going to be that, or, you know, if we pop this off, it's going to be this, and so on. So that's also going to be in big O1, so it's going to be return self.stack -1 1. Okay, and that should be it, I think. Let's see. All right, so that is it for this one. Now let's think of the time and space complexity here. So for the time and space, it's going to be pretty straightforward, right? Because we know that all of these need to be in big O of 1. So for time, it's going to be big O of 1 for every single one of these, right? This is big O of 1. Push is naturally big O of 1. Pop is naturally big O of 1. This is naturally big O of 1. And now we made our stack in a way where we can get min in big O of 1 and space. And so let's just say n is like the number of elements we are pushing or whatever, like the number of elements total. Then this would be like O of n, where, you know, like let's say this is, let's see, there's some value they give you, and then 3 to the 4th calls will be at most. So this would be like, if you just push 3 times 10 to the 4th times, it would be like something like that. If that's the number of calls, worst case scenario, all your calls are just push calls, and that would be space there. Okay, so that's all for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. It really helps grow it, and I'll see you in the next one. Thanks for watching.